All right, welcome to EE391 MM391. Let me share the screen. All right, this is EE391 MM391, Maintenance, Reliability, and Engineering Economics. Uh, uh, we are dealing with the engineering economics section of the course, and I hope you guys are coping well. The It's a bit mathematical, but not as difficult as some of the bigger engineering courses which you have done in your career here at during your studies of engineering at USP. All right. Without much ado, let's move on. Are you able to see my Microsoft Word document on your screen? Can somebody confirm that, Bhavik?
Yes, sir.
Yeah. All right. Okay. All right. Thank you. All right. So I think Gulab Das and Hafiz, I had appointed you guys to just guide me if any particular aspect of the screen or technical aspect is not right. And also, please keep a time. As soon as it's 5 to 11, let me know. All right, let's move on. Last week, not last week, on lecture number 2, so this is lecture number 2, we learned about something called a cash flow diagram, right? So we were looking at cash flow diagram. We looked at the rules of a cash flow diagram. All of those rules are on the Moodle shell. And we looked at two examples. Let me show you another example. Of a cash flow diagram. And this example is already posted on Moodle. Let me show this. Okay, so let's have a look at this question here. Guys, are you able to see the particular question on the are you able to see the particular question on the screen?
Yes, sir.
Yeah, okay. All right. So let's read that question. Before evaluating the economic merits of the proposed investment, XYZ Corporation insists that its engineers develop a cash flow diagram of the proposal. All right. An investment of $10,000 can be made that will produce a uniform annual revenue of $5,310 for 5 years, and then have a market recovery value of $2,000 at the end of year 5, EOY 5, right? Annual expenses will be $3,000 at the end of each year for operations and maintenance of the project. Draw a cash flow diagram. So, okay, so the first thing is there is a $10,000 investment. So, from your pocket, what is happening about $10,000? What can you tell me about the $10,000, guys? What can you tell me about this $10,000? That's a that's an investment. So, what is happening from your point of view? What is happening from your point of view? The $10,000 is
You're going out.
going out of your system, is going out of your business. So therefore, this $10,000 will be arrow. The 10K, right? What will it be? It'll be arrow downwards. All right. And when will that happen? In which year? In which time frame?
Zero.
Zero. Yes, thank you. Zero. Right. Now every year there's $5,310, right? Which is that's the revenue. So revenue is what direction is the direction of the arrow? Is upwards,
Up.
right? But right, but okay. So we're looking at annual, right? Let's look at what is happening annually, right? So revenue will be upwards. So let me just put a small arrow here indicating that that's upwards. And then there's again annual, right? Let's look at all the annual expenses first, right? Annual expenses is downwards, right? And so this $3,000 will be downwards. So upwards so annually you have got $5,310 going upwards and 3 grand going downwards. So therefore, what is the net? 53 upwards, 5310 upwards, and 3000 downwards. So what is the net what is the net effect, guys? What is the net effect on an annual basis when you have got upward arrow and downward arrow stacked on top of each other? What do you see that as? That is, what do you see that as, guys? Come on. Yes, 2310 going downwards, right? I mean, sorry, 2310
Upwards.
going upwards. Yes. And then right in the end, then this sentence over here, this sentence, for 5 years. 5 years means the timeline will have 5, right? That's another important thing. Then have a market recovery value of $2,000. So this $2,000 appears where? At the end of year 5. So this $5,000 will be what? $2,000 will be pointing upwards. What do we call this usually? We call it a recovery or salvage value. This $10,000 will be going, investment will always go downwards at year 0. Okay, that's at year 0. And this will happen at year 5. Okay, this will happen at year 5. All right, so let's have a look at the cash flow diagram. There we go. 10,000 going downwards. Then this is annual basis. How can we reduce this? If you look at this diagram, what is missing in this diagram? What have I done in this diagram which is incorrect? How can this diagram be further improved? Anyone? Can somebody tell me how can this diagram be further improved? Come on, guys, tell me. Anyone got an idea or wants to make a suggestion of how this diagram can be further improved? Well, if you look at this part here, what can be done about this? All of these guys.
Subtracted.
Yeah, you can make a single arrow of 2310, right? You can reduce each of those lines to 2310, so you don't have double sets of arrows. All right, and always the expenses are always on the dot on the end of the year. All right. Okay, something, if an expense happens in the middle of the year, you always show it at the end of the year. All right. Okay, so that's a simple diagram. That was another one which we have done. Okay. Now let's move on to our Microsoft Word. All right. Okay, so today is the 22nd of October, week 9, lecture 3. The other lectures are all here. I'm going to paste this, I'm going to upload this onto the Moodle shell, but I won't be writing much over here, right? I mean, this is just a guide. All these questions are already there. All right, let's do some warm-up exercises before we get into the real deal. Right, let's do some warm-up exercises before we get into the more difficult topics. Okay. All right. All right, guys. There we go. All right, let's have a look at this question here. Problem number 1. The landlord at your nearest apartment requires $1,000 rent deposit. Typically refers to as last month's rent. The law requires, okay, this doesn't happen in Fiji, although it should happen. It's already happening with the what do you call the in the case of the FEA deposits, but not yet with the landlord yet. The law requires that landlord pays 4% simple interest on deposits. If you live in the apartment for 3 years, how much interest does your landlord owe you? Right? So $1,000 rent, remember that extra bond, what do you call the bond? Bond is equal to, how much is the bond, guys? Bond is equal to what? 1,000. Yeah? So this is the extra rent, last month's rent, which in Fiji we call it bond. Are you guys familiar with the term bond? All right, okay. In Fiji, we call this bond. All right. Okay. Now, and the interest rate is equal to the interest rate is equal to, what is it, guys? Come on, come on. I want you to participate. 4%, but you convert 4% into decimal, that's 0.04. Now, it's using simple interest, right? So how much interest does he owe you? Right? Look at the question. How much interest does he owe you? So over here, when it's just written 4%, we simply assume that that's going to be what? 4%? What do we assume over here, guys? Come on. What do we assume? We assume it's per annum, right? We assume it's per annum. So 4% interest. So interest is equal to interest owed will equal to principal was what? Principal times rate times time. Oh, this is such a simple question. 1K, right? 1K times rate, right? 1K times rate of, what is rate? 0.04 times time of how many years, guys? 3 years. So what is the interest? Can somebody tell me? Yeah, okay. When, so note, let me just put this here. Note, if time interval of interest is not given, then we assume, what do we assume? Annual rate. Okay, right. So what does the landlord owe you? $120. Final bond back. Final bond back to be given, to be refunded. If why do we have bond, guys? Why do we have bond? Well, basically, if you damage the apartment, the landlord can use that to repair their apartment. All right, the landlord can use that to repair the apartment. So, final bond to be refunded to the tenant is what? 1120. This is when you exit the apartment in 3 years' time. All right, easy question, easy peasy. All right, let's now move on to the next problem. We call this problem in 1626. A Dutch West India company paid $24. Right, so this is very relevant to Fiji as well, because in Fiji too we had. In Fiji, we also have a situation where land was acquired. Land was acquired at a very low value. All right. So this happened in the USA. I've taken this out from a USA textbook. So it says in 1626, the Dutch West India Company paid $24 to purchase the island of Manhattan from the Native Americans. If the company had invested $24 in an account and paid 8% interest, actually that's quite high, how much would the investment be worth in 2016? Solve the problem using the account pays 8% simple interest, then solve it again using compound interest. Okay, let's do simple first. All right, simple. Okay, so what is it asking for? How much would the investment be worth? So it says asking us for the future value. Future value is equal to present value for simple interest. Present value into 1 plus I. Is that correct? I times T. Yeah, can somebody help me here? All right, so what do we get, guys? So what is our present value? Present value was $24. $24 multiplied by 1 plus I is 0.08 times Can somebody do the calculation of 1626 minus 2016? 2016 minus 1626. This is the time frame. What do we get, guys? How many years? Come on, guys. I need you guys to have your calculator. Don't waste my time.
90.
Yes, 390 years, right?
90. Yeah.
390 years. Thank you. 390 years. Okay, so that's 390. And what do we get? Anyone? 770.
772.8.
0.8. Okay, so the
772.8.
$24. Sorry. Yeah. So okay, 772.8. All right. So in simple interest, if simple interest was to be used, time frame, okay, is equals to 390 years. If simple interest was to be used, we have, you know, future value is equal to that much. Let's look at compound. Let's look at compound interest. Okay, future value is equal to what, guys? Can you tell me the formula? Future value is equal to present value. We've done this already, into 1 plus I to the power of 1 plus I to the power of
T.
T. All right. So let's do that. 1 plus I to the power of T. Okay, what is the present value, guys? It's $24. What is our I? 0.08. What is our T, guys? 390, right? Okay, what do we get? What do we get? I hope you have your calculator there. Please have your calculator ready. I don't want to waste time in our lectures waiting for you guys to respond. Right, give me the answer. Amit, what is the answer? Amit is saying something. No, I want a value, dollar value. I would like a dollar value. Somebody is saying $241. No way. Compound interest will always be more than thing interest. 24 times 1.08. Right. So this is the answer I'm getting. It's a long answer.
Yes, sir.
It's a very long answer. Okay. Not even $1 trillion. Check this out. Times 10.
It's 260 million.
No, not even that. Look at this. Look at this, guys. Look at this value which I'm writing over here. Let me zoom in for you. It's 2.07 times 10 to the power of 551. I don't know if this is correct. If 24 times 1.08.
The power of the.
Okay, sorry. Yeah, sorry. Yeah. Okay, this is the correct answer. 24 times 1.08 to the power. Hang on, let me just check one more time. Everyone's giving different answer.
603 times 10 to the power of the.
I think this is the answer, guys. The 260. One second. Let me just cross-check the answer. Sorry, this is the answer. That is the answer. I don't think that's in trillion, guys. You know, okay, 1 million has 6 zeros. How many zeros in 1 billion? Yeah, this is trillions. Yeah, okay, you're right, Caleb, you're right. So you could say that this is around, so a bit approximates it. When you have a value that big, you don't usually go down to the lower level. So because, like, for example, if you're dealing with the value of a car, you know, which is $50,000, you don't go and say, hey, you don't go and say, oh, my car is $55,560.26. The cents don't matter. The $26 doesn't matter. We just say $55,000, right? So it's $1 trillion, guys. Make sure that you get that right. So this is $260 trillion, right? So just remember how many zeros. How many zeros? So let's just have a side discussion. How many zeros? Zeros in $1 million. Okay, everybody knows this. Okay, how many zeros in $1 million? Anyone? 6. Right. 6. Right. How many zeros in the next level is billion? Billion is 9 zeros. Right. And how many zeros in trillion? Yes, 12. Right. So when you look at this 10 to the power of 14, so we just roll this back by 2 and then you add 12 zeros, so $260 trillion. All right, nice. Let's move on to the next question. I would like your active participation in the class so that we don't waste time in me asking you for your answers and all that. All right, let's move on to the next question. And the questions will get harder, guys. And this is the level which you will finally come to towards the end of the semester. If $500 was deposited into a savings account, what would be the account in 3 years from now if 6% compound interest was paid? Oh, this is very simple, something similar. Hey, by the way, let's just do a discussion on this particular. Let's just do a quick discussion on this particular what do you call thing. So the Indians, the Red Indians, the Native Americans, they sold this. This is true story, guys. By the way, they sold that land on which Manhattan Island is. Right? You know where Manhattan Island is? That's where the financial district. That's where Wall Street is. That's where the Twin Towers were. That's where all these the hub of New York's financial district is. Right? And they sold it for $24 to the Dutch West India Company. So you can imagine they would have had $260 trillion now if it was compounded. Even if you made it at 6% or 5%, still it would have been in the trillions of dollars. But they sold it for $24. All right? Okay? So, but if they would have just done a simple interest, it would have been nothing right now. Just $772. Right? Okay, let's do this one, guys. Future value is equal to present value into 1 plus I to the power of t. All right, 1 plus I to the power of t. Okay, present value is what? 500. I want you guys to have your calculators ready, guys. Have your calculators ready, right? 1 plus, what is the interest rate? Now this is really easy. Now by now this would have been peanuts for you guys. To the power of how many years, guys? 3 years. Okay, what do we get?
595.5.
$595.50. Is that correct? All right. Let's now look at this guy here. All right. Now this is we're going into deeper water now. Some new concepts. So this is the way I'll be teaching, guys. I will explain the concepts, but then at some point in time we've got to do a problem, because the nature of economics is a bit like engineering. We can't really do problems until you've done the concepts. Let's look at problem 4. Suppose a savings account pays 6% interest quarterly. Ah, look at that. Quarterly. That's a new word. Quarterly. What is your understanding of quarterly, guys? What do you understand by the word quarterly? Anyone? Speak up, guys. Speak up. Quarterly. What do you understand by the word quarterly? Yes, it's divide the year into quarters. So that means 12 months divide by 4, so which is equal to 3 months. So 3 months is what? 3 months is the same as quarter, year, set. Okay, quarterly. That's a new word. All right. How much money would be in the account at the end of 3 years? Up till now, what was our problem? Nature of our problems. What was the nature of the exercises which we've been doing? If you look at all our interest problems, what was the nature of the exercises, guys?
Interest on annual basis.
Yes, interest on annual basis. Now it's quarterly. So, okay, in the past we were doing problems with interest on annual basis. Guys, I would like you to have your exercise book ready. I don't want to go and waste time and type each and every word of our. I don't want to waste time in typing each and every word. I want you guys to handle some of the of the typing and so forth. Okay. All right. Um, all right. Now, let's now note down all our what we have. Our present value, which is equal to our principal. Present value is the principal. Is how much, guys? According to this problem number 4. Come on, tell me quickly.
500.
Yes, 500. 500. Right. Okay. Next. What is our interest rate? Our interest rate is equal to 6%, which is, we can say, 0.06. Fine. Fine. That's fine. Okay. Next. What else can you tell me? Well, our M, this new letter called M, all right? All right. There's a new letter called M, which is our time frame. We usually is the proper way to describe time, right? Okay. Our M is equal to okay, there's something known as time in annual, and this is the rate, right? It's 1/4 year. That's the compounding time frame. The M is the compounding time frame. Okay? Okay, the compounding time frame, or the rate, the point in time at which the bank does the thing. So quarter year is equal to 12 divided by 4, which is equal to 12 divided by 4 months, which is equals to 3 months. All right. Okay. So that's quarterly. All right. Now, let's now look at, we have to draw a table. All right. Okay, let's now draw this table now. Okay, um, we have our present value or principal. We have our I, our interest rate, right, which will be converted to R, and which we have our T, which is equals to N. N is the number of intervals. Okay, so time is in years, but N is in intervals. So let's now, in the first line, why don't we have a look at it from a point of view of so we have 500, right? Originally the question said 500. It said 6%, right, which is equals to 0.06, right? And our T was in years, it was 3 years, right? So T is in years. T is equals to 3 years. Everyone with me? Okay, now let's now convert it. Okay, let's now convert it. Let's now convert it into the new method. $500 will still be $500, right? Okay, $500 will still be $500. Now over here, we've got to note that our our compounding period, is equals to quarterly, right? So therefore, our interest rate, okay, so maybe the way to do it, guys, the way to have done it over here is, let me just give it some space. Okay, and I'm gonna draw an arrow. Oh, I don't like these arrows. Okay, and this will become their way, and this will become this thing here, right? $500, right? And this becomes this. Okay, all right. Now, so what we have, our new interest rate, which is R. So this was I was given as a function of 1 year, right? And taking into account an M, we now have to find R, which is equal to 6% divided by 4. Why divided by 4? Well, because that was 6% is annual interest rate, right? 6% is an annual interest rate, okay? And now we have to, whenever they mention the interest rate, it is given annually. So we have to divide by 4. So that equals to 1.5%. 1.5% is equal to 0.015. All right. Now, the 3 years, the time frame becomes, what does the time frame becomes? Well, basically we say N now, number of intervals, right? Number of intervals. So we've converted everything to a new dimension. It'll be 3 times 4, which is equals to, okay, which is equals to 12 intervals. There we go. We have 12 intervals now. We're talking about it in terms of intervals, right? Therefore, our future value, so after taking that into account, future value is equal to, so what we've done, we've converted the problem, is equals to present value, right, multiplied by 1 plus R to the power of N. 1 plus R to the power of N. Okay, and what do we get, guys? We get present value $500 into 1 plus, what is our R? 0.015 to the power of 12 to the power of 12. What do we get? Answer? Thank you. S111 36301. There we go. All right. So the key part over here is the present value part was okay, not too hard. The key difficulty here, it's not too difficult actually. What we did was, the crux of the matter was, we took it from interest rate, which was annually, and taking M, a compounding period, which is quarterly, right? Okay, we took M, which was quarterly, right? And then we converted using M to 0.015, okay? And we had 3 years, we took it down to 12 intervals, right? Okay. Now, so at this point in time, guys, I just want to introduce you to a particular topic which is called effective interest rate. Okay, I want to okay. Right. Okay. Now, this is a particular thing about effective interest rate. Now, basically, what effective interest rate is you take IEFF. Effective interest rate is, we've taken this 5.9, we've calculated this 597.90 based on the fact that our compounding period was quarterly, right? But the interest rate was given as annual. It's always annual, right? Okay. Okay, but it was paid out on a quarterly basis. Okay, so that's the difference over here. That even though the rate is given as an annual interest rate, the payout period was quarterly. So we had to cut that interest rate into 4 pieces, into 1.5% each, and then go ahead and do this. All right. So we end up with this formula. That 1 plus, if you look at the problem which we did, is we take our rate and then we divided it by M, all right? Rate over M. Maybe if I put this in brackets as well, and if I put that, so this is just the interest rate, guys. This is just the interest rate, okay? And then we take this to the power of M. I'm going to clean that up. Hang on. I'm just going to type it out. So that goes to the power, and this is I effective. So what we've done over here is, okay, so what we end up doing is, we have our rate. What does the word rate stand for? That is the nominal interest rate. And what is M over here, guys? Well, lowercase m is the number of compounding periods. So therefore, okay, based on the example, based on problem 2, problem number, what number was this, guys? Problem 4. Problem 4. What is the effective interest rate? Can somebody calculate that for me? So this formula, guys, I just want to mention something else. In this course, we are not too interested in the derivation of the formulas. Remember, we are not doing the whole degree. We are not doing a full degree in economics. We are engineering students. We are engineers, and all we are doing is we are doing a what do you call all we are doing is basically a course to support our engineering activities. All right. Okay, so we don't really need to learn how this formula got derived. Okay, we don't need to learn how this formula got derived. Okay, so this is only interest. It's not giving us the final answer. It's only giving us the interest, not giving us the future value. So what is the effective interest rate?
It's the formula.
So the formula is here for problem number 4. The problem number 4 is the one which we just did. Guys, by the way, okay, maybe I should have mentioned it earlier. All the questions, let me bring this across over here. Okay, if you are looking for these questions, hang on. By the way, all our lectures, how many of you have been able to watch these lectures? Lecture 1, Lecture 2, Lecture 3. These are all being recorded, and almost straight away I always upload that. This is the cash flow examples, the 2 which we have just done, right? And if you're looking for the problem which we are doing now, it's here. It's called in-class exercises, right? Oh, sorry, not that one. There'll be another one that's separate. Here, guys, in-class exercises week 9. There we go. Okay, in-class exercises. So these problems, the question paper, you may be wondering, where is the question sheet? How can I copy the questions? Well, it's all over here. It's on the Moodle shell. It's called in-class exercises for week 9. Can you see the word week 9 over there? All right. Okay. Let me just put this back. Okay, so based on problem 4, what is the effective interest rate? Anyone? Has anyone been able to calculate the effective interest rate? Amit, can you check that? I don't think it's 0.01. That seems to be 1.4%. Yeah, Caleb, that's right. 6.1 something percent. I'm getting 6.13% actually, but I'll take your value. I effective is equals to, all right. Okay, so your M over here is 4. That's 4. Okay. All right. Okay, guys. So this was just, what does effective interest rate mean? That basically is a comparison that, hey, if we wanted to earn the same amount or on interest rate which was done annually, what would we get? So in order to same interest rate which was paid out annually, right? So you need to have an interest rate of around about 6.12% in order to get that same value. If you have 6% paid out quarterly, you'll get a different value. If you have 6% paid out at the end of the year annually, all right, that's different as well. Okay, all right. Okay, now I'll skip over continuous compounding. We're not quite ready for that yet. We move on to another topic, guys. I want to talk about another topic. I want to talk about another topic. Sorry, maybe I need to do this one. So, I would like to do question 6 before we move on to the new topic. The new topic was going to be, by the way, it's going to be on a topic called annuity, right? But let's do all the problems on interest first before we do this. So problem 6, not yet. Okay, not yet. Right? We go to problem 6 now. Guys, you can see my Microsoft Word over here?
Say time's up.
Nice, okay. Time's up. It's on my clock, it's 10 to 11.
It's 10:50.
10:50, yeah, okay. We'll do 5 more minutes and then you guys can go to your next class. All right? Okay. All right. Right, let's have a look at this problem. Suppose you make $500 monthly deposits to a savings account. Suppose you make $500 monthly deposits to a savings account. Okay? That pays interest at a rate of 10% compounded quarterly. Find the balance of the account at the end of 10 years. Okay. Now, the key thing I want to start off with, guys, over here is, let me just get the diagram done. I just want to show you the diagram first. Okay. Okay. All right, guys. So the cash flow diagram. Okay, that's the cash flow diagram. All right, and then we have okay, we have 1. How many years, guys? 10, right? Now we have to apply our cash flow diagram to this sort of learning. Okay. 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 I hope we have 10 over here. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. All right. Nice. Okay. So that's our 10 years. All right. Okay. Now, what does the question say? You are making $500 monthly deposit to a savings account, right? $500 monthly deposit. So how will we draw this? It's gonna be, from your point of view, it's money going out, right? Because you're depositing. Okay, you're depositing, right? You don't have to draw all the arrows. I'll show you. You don't have to draw all the arrows. What do we do? What do we do? We draw a line like this to indicate. And of course, another thing which I wanted to show you was, oh man, I can't delete in the middle. Another way to draw something over here is, you do something like, have you seen this particular symbol when you draw a number line and then, you know, have you seen this symbol, right, to indicate a break, right? So you don't have to draw all the way till 10. You can draw 1, 2, 3 and then draw this break over here, draw this particular break over here, right, which will indicate that it is a continuous thing, right? Now and you're making monthly, oh, mistake, I made a mistake, monthly deposit to a savings account, find the balance of the account in 10 years. Oh, this is where the mistake is, guys. So select 10 years, guys, is how many months? Can somebody tell me? 10 years is how many months? We just finish off, we'll just draw the diagram, we won't solve the question. 10 years is how many months, guys? Anyone? 120 months. So this one is, this particular diagram is in terms of months. Okay, there we go. Right, and what we want to find out in the end, we want to find out what is our amount in the future. We want to find out our amount in the future. So that's our question. So I've put the question in diagram form, right? And now we have to do the calculation. And this is where the concept of annuity comes in. Okay, that is where the concept of annuity comes in. All right, that's it for this afternoon. Can we change the amount deposited yearly? No, of course, in real life, Tavake, in real life you can change the amount. You can change the amount. So maybe one month you deposit 500, another month you deposit some other amount. Of course, you can change the amount deposited on a monthly or yearly. But in this question it says 500, right? So we are sticking to the question. I think we are now out of time. It's 10:55 on my clock. Usually, can somebody guide me? What time do we finish the lecture? Do we finish the lecture on 11 o'clock on the dot, or during Zoom lectures? What do you guys do? Is Hafiz here? Hafiz, Bhavish?
So we normally end at 50 minutes.
Oh, okay, all right, okay. So we'll try and in this thing we'll keep it at 50 to 55 minutes. We'll try and stop so that you guys can finish off the lecture. All right, okay, guys, that's it. But we have not finished problem 6 yet. I want you guys to go and make sure that you have a look at these questions. All right, the questions are already on the Moodle shell, and I hope you've got your exercise book there. All right, thank you, and we'll see you in the next lecture on Monday. All right, guys, goodbye.